I was working on a new double power supply with more energy out. This one only can give out, say, 8 watt, but I wanted to make a power supply, a double power supply, with, say, approximately 2 times 16 watt for more experiments with audio amplifiers that need a double power supply. So here are the components that I'm going to use, etc, etc. But the most important thing is, of course, when you make a double power supply, you must be able to set the output voltage both in the positive and in the negative way, and also you need to see the output current. And that's what this video is all about. I've used two very simple left and right microampere meters of the 1970s. Of course, you can also use, say, modern microampere meters. They have to go in the range of 50 microampere up to 500 microampere. That's 0.5 milliampere. Anyway, the shunt is here. And the principle of the shunt is very, very easy to understand. In a certain way, I have shortcut this extremely sensitive microampere meter with a piece of wire. And here is that piece of wire. The best thing to do that is to do that experimentally. Because for hobby purposes it's very difficult to measure ohms resistances in the order of 0.01 ohms, etc, etc. There are certain circuits for that with electronics, but anyway, the most simple thing is take a piece of wire. In this case I took 1 meter isolated copper wire with a massive core of 0.5 millimeters, and it gave me this result. It is all about current. So I use now my variable power supply. You need absolutely to calibrate this circuit a variable power supply with a variable output current. My safety resistor is now here 5 ohms, and let's see what happens when we change the current in the circuit. And the current is of course related to the voltage, but the only thing that we do now is measuring that current. Well, this is the schematic, very, very simple. This is the shunt, and it's now this piece of wire, copper wire, that shortcuts the very sensitive microampere meter. We change now the current via the voltage, etc. So now we see here that we have 0.8 volts. We have 500 milliampere. I'm now going to lift up the current. Let's see what it will bring. Lift up the current now to this value here. And the meter that I needed for calibration, the pointer moves out too fierce. At the moment I don't have a digital meter. Use in this case of course a digital meter, digital ampere meter, to get very precise insight how much current is flowing in the circuit here. So it's 1 ampere here, 1.9 volts. That is not very relevant. So now the meter works between 1 ampere. 1 ampere is now the maximum with that specific shunt, and now I bring down the current out of my power supply. So where will it work? Well, now this meter also gets in a good relation. It's now 200 milliampere approximately. So here we have 200 milliampere, and when I lift up the current out of my power supply we go to 1 ampere. So this is a very good range, and of course you can take the plastic board out and then glue to the scale piece of paper where you indicate with a pencil the different currents. Very easy to do, no problem. Don't have to buy very expensive ampere meters, though I have to say when you buy them via Ali at the moment in 2025, they are extremely cheap. So perhaps no need to do this experiment, but anyway, it shows how to do it. How to use very sensitive microampere meters as ampere meters, ammeters. In the order, even in the order of 3 ampere to 10 ampere DC. Thanks for watching.